having looked at polynomials in general, we're going to take a minute and look at some specific polynomials. We're first going to look at linear functions, and then in the next video we'll look at quadratic functions. Linear functions is when, remember, for a polynomial we had the degree being represented by n. Here in a linear function the degree is 1. So the specific form of a linear function is a1 x plus a naught. Okay, and then with that, let me actually just hide some of this. There are many different forms that a line can take on. We're going to focus on 3 of them, and then there are other forms, specifically for a horizontal or vertical line, but we'll leave those for you to explore on your own. So the 3 different forms, slope-intercept is the one that most people remember. That's y is equal to mx plus b. M represents the slope, and we'll talk about slope in just a minute here. B we call our y-intercept. Okay, so again, y-intercept, that means the place where it intersects the y-axis. Okay, so y value is the b value, and then the x value for that given point is 0. Point slope form, y minus y1 is equal to m times x minus x sub 1. M again is the slope, and then now x sub 1 and y sub 1. That is the point that we're given. So again, these different forms come in handy based on what information you're being given. So if you're given a point and a slope, or similarly 2 points, point slope is probably the easiest to work with. But if you're given the y-intercept and a slope, certainly work with slope-intercept form. General form is ax plus by plus c is equal to 0. A, b, c are real numbers. This one, not immediately useful to us right now. If you continue on in mathematics, when you study matrix theory, it'll come in handy there. Okay, and then I mentioned slope. We all kind of remember this, hopefully, from previous courses, but it's really the steepness of a line. We talk about it as the ratio of vertical change to horizontal change. So rise over run is what we commonly remember. We do see this notation later on in the course. The triangle, it's not triangle, it's called delta. It's a Greek letter delta. Delta y over delta x, representing the change in y over the change in x. And again, if we know 2 points, certainly we can just compute their slope by subtracting the corresponding parts. And notice that they have to be lined up in order. If you transpose the two, so if you have x sub 1 over x or minus x sub 2, you will not get the correct slope. You'll get the negative slope. And then remember, to interpret this, we always want to be able to verbalize in mathematics what we're doing, and we say that for 1 unit increase in the independent variable, there's a change of m units in the dependent variable, the y variable. Okay, and specifically, linear functions come in very, very handy, and actually more so their properties, when we talk about average rate of change. So again, we're given the graph of f down here, the equations here. We want to know what the average rate of change is in f from when x is 2 to x is 6. So if I were to identify those points, okay, 2, that's right here, so our y value is at 3. And then at 6, I go over here, that's right down here, y value of minus 5. Okay, well, average means that I need to take the average of the components. So really, if I want to determine a formula for the average rate of change, it's really just the vertical change over the horizontal change, or delta y over delta x. So here, if I compute this, the average rate of change, well, the y values, I can pick whichever one I want to start with. I'll start with the 6 for convenience. So the y value at 6 is minus 5. So minus 5 minus, and then now at 2, the y value is 3. So 5 minus 3 all over. And then I need to do 6 minus 2. Okay, and do that computation, and that's a minus 8 over 4. That's a minus 2 when all is said and done. Okay, and again, verbalizing what this means. On average, and this is kind of a generic statement. On average between, and we would fill in the two the two independent variable values, so between 2 and 6, for a 1 unit increase in the independent variable in x. Okay, so replace independent variable with just x. There is a change. There is a change of, and then -2 in the function value. Okay, so just fill in that spot. And now one important thing is if I were to connect these dots with a line, okay, and then of course it would extend on forever. The slope of that line, well, that line that I just drew, this is called the secant line. Okay, let me write that out. It's down there, but this is called the secant line. And the slope of that secant line is just our average rate of change. Okay, there are a couple problems that do talk about this, so please feel free to reference this, and stay tuned for quadratic functions.